Hello and welcome to Merlin Tuition. Today we are going to do our third and final set of examples on how to deal with reverse chain rule. And we're going to look at what happens when you have limits in your integrals. So, these are our two questions. If you need to take a pause for a moment, do so now. And I'm going to start solving. So we have our first question here, and we are integrating between 1 and root 6. As we've done before, we're going to look for our function of a function, so we have the square root of x squared plus 3. And we're going to take that internal function and make that u. U equals x squared plus 3. And so we are now integrating 5x u to the half. And we want to integrate with respect to u, so we have to do dx by du. And that's again because dx is dx by du from our chain rule. We need to find our dx by du, so du by dx is 2x, dx by du is 1 over 2x. But I haven't got my limits in at the moment, and that's a problem because those limits were in terms of x, and we are dealing with them now in terms of u, so we can't just write 1 and root 6 in there anymore. Now it is possible to find those limits, and when we move on to the next topic, which is integration by substitution, which works with this, I'm going to talk about that properly. For now, however, I'm just going to label them A and B, and it is vital if you do a question like this in this way that you label them A and B. Because just saying they are limits, they're not the same, we don't know what they are. And actually it doesn't matter because we're going to get rid of them in a moment. We have our limits again. A and B, 5x u to the half, dx by du is 1 over 2x, x's cancel, that should be A and B, and so we have 5 over 2 integrating between A and B of u to the half du. That is integratable, so it is 5 over 2. Now we're going in limits, so we need our square brackets. U to the 3 over 2 times 2 over 3 between A and B. Now if we change it back to x at this point, well, our limits before were in terms of x, are 1 and root 6. So once you sub it back into x, we can use those limits correctly again. We have 5 over 2 times 2/3. X in this case was x squared plus 3. Sorry, u was x squared plus 3. X squared plus 3. And that is to the 3 over 2. And that is now between 1 and root 6, because those were our limits there. And so we have stored with these dummy variables here, a and b, or these dummy constants even, a and b. And we've had to put them in. It would be wrong workings not to, but we can just put them back in terms of x again at this point here. So let's just move it down a touch. Now we sub those in. We have 5 over 2 times 2 over 3, lots of root 6 squared plus 3 to the 3 over 2 minus 1 squared plus 3 over 2. This nicely cancels to be 5/3, and we get, this is root 6 is 6 plus 3 is 9, so we get 9 to the 3 over 2 minus 3 plus 1 squared is 4, 3 over 2. Now obviously you can use a calculator here, but just finishing this off, you have 5/3, 27 minus 8, which is 95 over 3. Again, should have had equal signs all the way up here to say this is all the same stuff. I equals. Now, again, that is too much work. You don't have to do that every time, but that is actually what we are doing. But what we are doing here is we are integrating between a lower and an upper limit of f dash of x times f of x to the n, and there's some constant. Now this a and b are just the two limits, because this is all algebraic right now. When we integrate that, what that becomes is k times f of x to the n plus 1 over n plus 1 between those limits. And so, if we have a look at our question, we had 5x square root of x squared plus 3 dx. That is 5 over 2, that's my k, times 2x square root x squared plus 3 dx. 2x is the differential of our internal function, that's our internal function, and so it equates to 5 over 2 times x squared plus 3 to the 3 over 2, I've increased the power by 1, divided by 3 over 2, which is the same as timesing by 2 over 3. We left the limits out, so our limits here are 1 and root 6. 1 root 6 between 1 and root 6. So that is, these numbers can just come out. 5/3 x squared plus 3 to 3 over 2 between 1 and root 6. That is that. So I'm not going to finish this off. We'll come to the same thing again. Okay. Final example. In this case, we're given an unknown theta, but we're told what our integral actually integrates to. And so at this point, I'm going to stop using the long method that we've done every time so far and just show it to you using the shorthand method. We are here integrating in our limits f dash of x times f of x to the n dx, and that integrates to f of x to the n plus 1 all over n plus 1 between our limits. In this case, f of x is sine, f dash of x is cos. So if I integrate between 0 and theta of cos x sine squared x dx, that just equals sine cubed x over 3 between 0 and theta. And if you didn't like that step, what you should do is you should now go for it yourself using all the methods that I have shown you before to get down to this step. Now this here is our integral. And we can sub our terms in, and we'll get sine cubed theta over 3 minus sine cubed 0 over 3. And sine cubed of 0 is 0, so it is sine cubed theta over 3. But I equaled root 3 over 8. And so sine cubed theta over 3 equals root 3 over 8. And so sine cubed theta equals 3 root 3 over 8. If we cube root both sides, we get sine theta equals root 3 over 2. Now, we can solve that, and the inverse sine of root 3 over 2 gives us pi by 3. And so we have theta is pi by 3. And our next term is always pi minus that. So it's 2 pi by 3. And then we can do 2 pi minus as well, but that will be outside of our range because our theta ranges were only between 0 and pi by 2. So that's also out of range. So the only value theta can be is pi by 3. And there we go. At this point, you have all the skills required to do your reverse chain rule on your own. Happy hunting.